Hello everyone. Today we're going to answer the question, what can you do with Kinesis Data Streams? And today we're going to explore this topic and talk about what are the main difference between data streams and queues or message buses, how Kinesis can let you process large batches of messages in near real time, why you might want to use Kinesis as a queue or a pub sub in some particular scenarios. And also we are going to explore a few different ways to use Kinesis with the focus on avoiding too much complexity. My name is Luciano and I'm joined by Eoin, and this is AWS Bites podcast. So this is one of our last episodes in our series of AWS events services. And we are now focusing on streaming data. So I suppose the first question that we should try to answer is, what is streaming? What do we mean by that? And in particular, in the context of Kinesis Data Streams, what are the pieces of functionality that we get from this particular service? What do you think, Eoin?
Kinesis Data Streams we're talking about. So this is a fully managed event streaming service. So yeah, like you say, streaming is different to queuing and pub subsystems, the ones we've talked about already. So we should probably talk about what streaming is and how it's subtly but quite different. With streaming, you're talking about processing continuous streams of events in near real time, and typically in batches, right? Larger batches. With SNS or SQS, you might be talking about individual messages. Normally, they're standalone units. But with pub subs, you're talking about single message to fanning out to multiple consumers. But streaming, you're typically talking about larger volumes of messages from multiple producers being processed in bulk. So in batches by one or more consumers and more or less in real time. So you're really talking about a continuous stream of batches of records. And another difference with streaming, with things like Kinesis and Kafka, it retains the records even after they've been processed. So you can always have new consumers join, or you can reprocess data by going back to the data that's stored, depending on how long you've configured the retention of your streams.
Yeah, that can be very useful also when you have a bug in your code and you realize that maybe your processing didn't really do what you wanted to do in the first place. You can fix the bug and then basically rewind your ingestion, start from scratch and re-ingest everything again.
Yeah, that's true. That's true. I mean, we should also say that even though we're clarifying the differences between streaming and queues or pub sub, it's actually very common, well, not uncommon, I would say, for people to use Kinesis or Kafka as a queuing system or as a pub sub system. And then there's the question, why would you do that? And I suppose you'd only really do that if you need some of the specific features that Kinesis or Kafka provide that aren't provided with SQS or SNS. So those, we'll go into those in a bit more detail, but we should probably do our usual rundown through some of the use cases for Kinesis Data Streams. Where should we start?
Yeah, I always like our e-commerce example. So in the context of an e-commerce, how can we avail of Kinesis Data Stream? Like, what kind of utility can we get from this service? And one example that we mentioned before in one of our other episodes was if you need to collect clicks, let's say, or mouse movements from the users in the e-commerce, because that will give us an information what kind of products they're possibly interested in. What we could do is that we can collect this data almost in real time from the UI, send it to a Kinesis data stream, and then we can have some processing logic that it's getting the data in real time, figuring out which products maybe are relevant for the users, and we can send this data back maybe to a WebSocket or some other API and refresh the UI in real time with interesting suggestions. So that's a cool use case, and we could definitely implement that with Kinesis data streams. Also, another thing that I have done in the past is basically you can capture logs, for instance, from CloudWatch logs or other sources, and you can store them in Kinesis data streams, and then you can let the Lambda integration process these logs pretty much in real time, and you can do all sorts of things with that. One use case I've done before is basically if you store things that allow you to extrapolate metrics, then from your Lambda, you can actually re-ingest this information as CloudWatch metrics. So you can basically transform logs into metrics by using Kinesis Data Stream as a quick way to transport the data and then start some processing. Any other example comes to mind on your side, Owen?
Yeah, well, speaking of metrics, there are quite often a few cases where AWS CloudWatch metrics for some services, they're missing some of the metrics you want. Often for things like when you're trying to track the number of resources for pricing, you want to be alerted when you're using too many containers or number of EC2 instances. You can use, the last time we were talking about event bridge events that come from AWS out of the box. So you'll get state transition events when a container starts or stops, similar with EC2 instances. With Event Bridge, it integrates into Kinesis Data Streams quite easily. So you can set a data stream as your target for an Event Bridge rule. You can take all of those events that are coming relating to ECS containers, and then you can process them in batches in Lambda or another consumer and use it to figure out, okay, at any given point in time, how many containers are running in each state. What is the duration of a running container? And you can create your own custom metrics then. This is something I've done a few times with things like ECS and AWS Batch, where the metrics out of the box have a few gaps, and it works pretty well. I suppose you also see other interesting use cases, like people are building a delivery service, like Uber, Deliveroo, that kind of service. If you can imagine an architecture for that system, you've got a lot of real-time event processing. So you're collecting orders, you're collecting responses from drivers. All of those cases are things where you would say, okay, this is a delivery stream. I could use Kinesis or Kafka for this.
Yeah, absolutely. Yeah, we should maybe talk now about some of the main features of Kinesis Data Stream. So we said that the data is going to stay there, but of course it's not going to stay there indefinitely. You can configure a retention time. By default it's 24 hours, but you can scale that up to 1 year. So you can keep your data around for a very long time if you want to. Another thing that is worth mentioning is that you get very, very good latency. It's under a second to basically when you store that first record from when you actually consume it, and can be around a second or 70 milliseconds depending on how you use it. So we'll talk more about this later on. Yeah. Okay. And then messages in Kinesis are called records, as you might have guessed at this point. But a record generally has a sequence number and a partition key. And then there is, of course, a data part, so the payload itself, which is the part you are interested in processing. Another thing that we mentioned to some extent, but is worth highlighting a little bit more in detail, is the concept of shards. Shards are the unit of scale for Kinesis. And I suppose you can imagine shards as different locations where the data is being distributed. And partition keys are basically is the concept used to select, given a record, in which shard is going to end up. So this is very similar to many other distributed systems. So it's not magic in that sense. It uses the same principles as many other distributed systems. And of course, that gives us other guarantees. So you're not going to have absolute ordering of messages, but you will have relative ordering per shard. So only the data ending up in the same shard will respect partial ordering there. But if you fetch data from different shards, they will not necessarily be in order.
Exactly. That's a little bit like what we talked about SQS and message group IDs. It's a similar principle. Yeah. And of course, what that means is that with guaranteed ordering, you always have physics getting in the way and putting limits on you. So we should talk about those limits, because the limits of Kinesis and what you can do with a single shard really dictate the architecture of your system. So normally we talk about quotas and limits at the end, but we're going to talk about this a little bit earlier, because you get very fixed capacity, and you have to think about that and how it impacts the architecture, the scalability, and the level of concurrency. Makes your architecture a little bit more complex, and it kind of makes you realize that streaming data applications are inherently more complex than queues and PubSub. So it's probably worth saying at this point, if you don't need any of the specific characteristics of these services, it's always better to stick with something simple like SQS and SN Event Bridge, because they do give you can get low latency and scale and massive concurrency with those systems. You don't need a streaming data system to get that. It's only if you really have specific needs that some of the Kinesis or Kafka features will give you just around the number of messages you can get in a batch, for example, or the integrations with specific other systems. Those are the only reasons where you really need to reach for those more complex streaming applications. But anyway, with that out of the way, what are these limits? So we have strict limits of 1 megabyte write per shard or 1,000 records per second write capacity. So that's how much you can write per shard in a second. Or you can read 2 megabytes or 2,000 records per second from a shard. So the read capacity is double the write capacity, and it's very easy to remember because it's 1 megabyte and 1,000 for write. But you're limited to how often you...
On this one, I want to mention something, because the first time I noticed these limits, I was a little bit confused. I was thinking, okay, why can you write at a certain speed and then you can read at double that speed? And that might seem counterintuitive at first, but we need to keep in mind that you might have multiple consumers. So you are writing from one side, but you have multiple consumers on the other side. And these limits needs to be accounted for all the consumers at the same time. So they compound. They are not specific per consumers.
Exactly. Yeah, and you also sometimes need to read more than you're writing, because you might be catch up. You might be reading from older records in the stream, so you have to catch up. So you can't catch up if the limits would be only the same as the write limit. But there's also the 5 get. You can only call get records. You can only have 5 read transactions per shard per second as well, which is another interesting one. So that means you can read up, like with a single read transaction, you can actually read 10,000 records. So we were both talking about, this is about batches. That gives you an indication, right? In one read transaction, you might be reading 10,000 records or 50 megabytes. So you just need to think about that when you're thinking about latency. You might say, okay, I can get like 50 milliseconds. I've observed that I can get messages in 50 milliseconds. So if I just call get records 20 times a second, that's fine. But you can only call it 5 times per second. So that's really the unit of scale, the size. You can think about if you know what rate you're going to be ingesting at and reading at, then you can do the maths and figure the rest out. As regards other limits, soft limits, you have a soft limit of either 200 or 500 shards per stream, depending on the region, but you can always increase that to, I think, tens of thousands of shards. So you can really get high volumes through Kinesis. And I guess since we're talking about units of scale, we know the limits. What do you do then? How do you scale? Or how does Kinesis scale for you?
Yeah, that's an interesting one, and it's a little bit of a controversial topic, because in some cases you will hear Kinesis being addressed as a serverless service, but I suppose that really depends on the definition of serverless that you have in mind.
Yeah.
Sometimes the argument to that is that it doesn't really scale to zero. That means that you have to think about how do you provision Kinesis data streams upfront. And once you do that, if you don't use them, they don't automatically scale to zero. So an interesting news on this field was that in the last reInvent, AWS announced the on-demand mode for Kinesis data stream, which helps a little bit to see Kinesis data stream in a more serverless way. But again, they don't scale to zero. So you have to worry less about provisioning them in advance, but they will never scale to zero. And even if you don't use them, there is always some cost that you will need to pay anyway. So it's interesting. Like, you could argue it's serverless, but not quite. Anyway, talking about scalability, at this point, we understand that the shard is probably the primary unit to understand how a Kinesis data stream will scale. And interesting thing is that if you use the provision mode, it's up to you to basically do all the calculations up front and allocate the number of shards that you think are going to be enough for you to sustain your read and write throughput. You can change that over time. Like if you realize at some point you need more, or you over provision and you want to scale it down, you can do that, but there are restrictions. You can do it only 10 times per day, meaning a 24-hour period. And then it's interesting that you can only either double or decrease to half the original number of shards. Funny enough, you can do arbitrary amounts if you use the web UI, but you can see that the value fluctuates until it actually converts to the value you want. So there is some magic there. If you use the web UI, it looks like you can go to any arbitrary number, but there is still this restriction where you are doubling and decreasing in half until you get to the number you really want to use.
Yeah. And of course, the reason for that essentially is because if you look at the APIs for doing it, if you're implementing this programmatically, as a lot of people do, especially before on-demand mode came out, the way you increase the number of shards is by splitting existing shards. And the way you reduce the number of shards is by merging two existing shards together. So that's where the doubling and the half comes from. But I guess, yeah, you don't have to do that so much. So how does on-demand mode work then?
Yeah, on-demand mode is pretty much AWS will figure it out for you, and it's based on the actual throughput that you have while working on the Kinesis data stream. So you start with a default write capacity of 4 megabytes per second or 4,000 records, which is probably 4 shards behind the scenes. We just don't have to worry too much about the concept of shards in this case. And if you keep writing and reading more, so if you will need more capacity, the on-demand mode will automatically scale the stream, and you will be able to go up to 200 megabytes per second or 200,000 records for writing into the stream. Of course, it doesn't scale instantaneously, so be careful with that. Like if you have spikes that are like instantaneously doubling or tripling your throughput, don't expect to scale immediately. It will take a little bit of time. I think it's around 15 minutes before it will decide to double the capacity. So you might still get throttled with this approach if you have spikes. So be careful with that.
Yeah, I also think it's kind of worth mentioning that while it says you get a default write capacity of 4 megabytes and 4,000 records, and like you say, that equates to 4 shards. And you might think, oh, well, that's great. I don't have to worry about my shards anymore. Of course, at the consumption side, you need to think about the read, the limits, because you still have a per shard read limit. And if you've got 4 shards, you kind of need to know about that because it affects the concurrency of your consumers. And if we'll talk a little bit more about Lambda, but with Lambda, the number of invocations of Lambda will depend on the number of shards. So if you don't know the number of shards, it's very difficult to predict how many Lambdas are going to be invoked. So you always need to kind of think about that anyway.
That's
and
true,
even if it's happening in an on-demand fashion, you should probably do some monitoring on that.
Absolutely, yeah. Do we want to mention also there is another mode called enhanced fan out, which it makes sense. It's relevant only for consumers, and it's a different way that allows you to consume the data, because in this case you basically get a pipe. So every consumer will have a pipe, and the capacity of how much data you can read per second is basically per consumer in this case, and it goes up to 2 megabytes per second per shard, if I remember correctly. So the interesting thing is that
I guess sorry, Luciano, but yeah, I guess the interesting thing here is that with these limits, you mentioned the read limit of 2,000 and how it's greater than the write limit, but it's shared with your consumers. So like you said, you've got 5, if you have, let's say 2 consumers, they're sharing that, they get 1,000 each or a megabyte each. And that can be quite difficult if you've got multiple consumers. If you've got, one consumer that's aggregating events, one that's sending them to Firehose, and another one that's doing another Lambda-based aggregation. With enhanced fan out, you're basically saying, give me a dedicated pipe, and it's using HTTP2, and instead of you pulling the events, it's pushing them to you. So you essentially get 2,000 records or 2 megabytes per shard per consumer, right, instead of per shard, which is really good. Yeah, and you also get lower latency for free as well, because it's push mode. It can give you that latency of I think it says average 70 milliseconds instead of the average of 200 milliseconds with a standard shared consumer.
Yeah, thanks for clarifying that. Do you want to mention something quickly about the different pricing model, especially comparing the on-demand and the provision mode?
Yeah, this was a surprise, because a lot of people have been anticipating an on-demand or kind of serverless version of Kinesis for a while, and the slight disappointment came from the pricing, because it looks like in order to take advantage of on-demand mode, it doesn't immediately make it free, because it doesn't scale down to 0. So the kind of entry-level pricing for each, if you compare them, on-demand is actually more expensive than provisioned, because with on-demand you pay per stream per hour, and with provision you pay per shard per hour. So if you go with provisioned, the lowest provisioned level, which is 1 shard, you'll pay about a third, almost a quarter of the price of the on-demand baseline, which is around 4.5 cents per hour. Because on-demand is charging you per stream. It's giving you 4 shards out of the box. But if you don't use any of those shards, you're still being charged, right? So the baseline is higher for on-demand. And then with on-demand, it is kind of more serverless in the sense that it's charging you by the data that's flowing through the system, the data ingested and the data retrieved. Whereas with provisioned, you're paid by the shard, and then the shard gives you a capacity. You don't pay as you read. So it depends. I think the if you're trying to judge which is the right mode from a pricing point of view, you just have to compare your use case. It's going to vary for everybody. Some cases on demand will be cheaper. In other cases, provision will be cheaper. It depends on your trade-offs between performance, scalability, cost, and the value you're getting out of this feature. So it's really a business context.
How frequent do you actually write and read to and from the stream? Like, is it a constant stream, or is it something that can be a little bit more spiky? Yeah. All right. In terms of observability, because we slightly mentioned that before, but yeah, let's see maybe what are the most interesting metrics to look after to see if we are actually using the data streams correctly. So of course the first one, and probably the most obvious, is the iterator age, which can basically tell you the age of, let's say, the message, the latest messages you still have to process. So it's kind of an indicator of how far behind are you in the stream in consuming it. So it's a good way to see if your read capacity is not well tuned, I suppose, to the rate of producing data. So keep that in mind, because that might be very useful for you to guarantee that you are actually producing and consuming data as in real time as possible. Another one is throttling, and this is a little bit of a controversial topic in my opinion, because it's you can get accurate throttling metrics, because of course you'll get a data point every time you get throttled. But if you want to try to anticipate throttling, you have to do a little bit of maths on your own, and you can look at the get record and put record metrics. And the problem with those metrics is that the ones you get by default in CloudWatch, they are aggregated by minute. So if you have very bursty data producing and consuming the data, then you don't really know in a minute how much are you doing, for instance, in a second. So you only see the minute value. So you might see a value that looks okay, but then you see that at the same time you got a throttling for that particular minute. So be careful with that. And if you really have bursty use cases, maybe you want to do something a little bit more custom and maybe record metrics on your own to make sure that you understand, if you want to understand in advance when you might incur in throttling. Otherwise, the simple way of looking at this is just look at the metrics for when the throttling actually happens in reading and writing, so when you exceed the capacity. And then you can adjust your shards, or you can adjust your processing to avoid the throttling in the future. Sometimes even a little bit of throttling can be fine, because of course the SDK will retry for you. So if that's not really slowing down your pipeline, probably you don't even need to change the shard. So keep a look at these metrics because they will be telling you a lot, and you can understand whether you need to change some configuration in how you read and write the data or the number of shards itself. So at this point, maybe we should talk. I think you probably have a fair idea on how to use Kinesis Data Stream, but it's maybe good to do a recap and maybe provide a little bit more details, right?
Yeah. Okay. I'll try. There's generally one way I usually try to use Kinesis, but I'll talk about that last because there are kind of three different ways to use it. There's the API, there's the libraries, and then you've got Lambda. And if we talk about the API usage first, it probably gives you a sense of how it works under the hood, even if you use some of the abstractions. So when you're producing messages and sending them into Kinesis, there's a put records API, and it allows you to put 500 records at a given API request. And it does that really quickly as well. So when you're comparing to queuing or PubSub, Kinesis is all about lots of messages, big batches. You can put in 500 in a single request. You'll remember, like with SNS and SQS, it's 10 with the batch APIs. So you can put in a megabyte total per record, or up to 5 megabytes for the whole request. So there's a bit of maths to be done there as well. And when you specify that, you put in the partition key, which you already mentioned. So the partition key is useful for dictating ordering and also the shard it's allocated to. So AWS will take your partition key, produce a hash of it, and use that hash to dictate which shard your message goes into. Because every shard basically has a range of hash keys that it will accept. So it's just basically an integer allocation for each shard, a range of integers. But if you want to override that and you want to really have lots of fine control over which shard a message goes into, you can actually override the key and specify that integer in the message as a decimal value, and that's called the explicit hash key. Generally, you don't have to do that, but in some cases, if you want to control that ordering and the shard allocation yourself, you can do that. I suppose since you're putting 500 messages as well, it's also really important. I think a lot of people using Kinesis have been here. If you use the put records API, you have to ensure that you handle the errors that come back, because you can get partial success. And the put records API will tell you which ones have failed, and then you need to reprocess those. So it's not like you're going to get an exception or just an error code back. You have to look at the error response and figure out which ones have succeeded and which ones have failed and redrive. So that's the production side, the producer. But if we look at the consumer side, retrieving manually using the API, there's quite a lot of complexity to it, or at least there's a lot of heavy lifting. Because you've got multiple shards, you can call get records for a single shard. So then you need to first of all, find out how many shards there are. You establish an iterator by calling get shard iterator, and the iterator is like a pointer that the service is maintaining for you. And then with that pointer, you call get records. And when you establish your connection, get an iterator, you can specify whether you want to read from the latest message, the oldest message in the stream, or you can specify a specific point in time or a specific record. And then once you have your iterator, you call get records in sequence, and you can do it up to 5 times per second. And like we said already, I think you can get 10,000 messages in each get records request. And then it's essentially like pagination after that. But of course, there's a bit of complexity in that, managing multiple shards. You might need like multi-threading to do that. You have to keep track of where each thread is storing its, what shard each thread is retrieving from. And that's why
one good analogy that we can use to understand really what's going on there is that imagine that every single shard is a file that where all the producers are pretty much appending more and more data, while at the same time you have consumers that have a pointer in every single file trying to track, okay, this is the point where I arrived consuming the data, and they need to figure out how to move forward, not just on one file, but for every single shard you have like one file. So multiple files, multiple pointers with data coming in all the time in every single file.
Yeah, I mean, these systems are ultimately very fully featured distributed logs. And I do like that. I think that's a really good analogy. If you think of each shard or partition as just a text file, and every record is on a line, and then just need to keep track of the line number, and that's like your iterator. I mentioned that there's complexity here. So the Kinesis client library is a consumer library written in Java that AWS provides to make this a bit easier. Now, you do have to understand how it works a little bit. It manages that pool of workers and multi-threading for you, and it uses DynamoDB to track the state. So it can recover, and it can keep track of things as shards increase and decrease. It is written in Java. It does have some bindings for other languages like Node.js and Python that essentially use the Java process running as a daemon and use standard input and standard output to communicate with the Node.js or the Python process. So that's the consumer library. But there's also a producer library, the KPL, and that allows you to send messages, but it has multi-threading, retry logic, batching in there for you. And it can also try to reduce the chances that you're going to get throttled on, the number of messages per second limit by packing large numbers of small messages into a single record. And that's something that might be complex to implement yourself, but if you use the producer library and the consumer library together, it happens seamlessly for you. So I think especially if you're in a Java ecosystem and you're using instances or containers with Kinesis, those libraries are a good fit. But you still have to understand how they work. You still have to manage the extra resources. So the third way of using Kinesis is definitely my favorite, and that's with Lambda. So I've talked enough about the first two. Do you want to try cover how Lambda works with the event source mapping that we talked about previously?
Sure. Yeah, I'll try to explain how that works, but feel free to add more if I'm missing any important detail. So we already explored something similar when we talk about SQS, where basically we said SQS has a bunch of APIs for you to fetch the data, but then when you use it with Lambda, it becomes a little bit more magic and you get a lot of stuff magically integrated and working well out of the box. Yeah. And the reason why that happens is because Lambda has this component called event source mapping, which is basically something that can be used to pull information and trigger a Lambda for you. So in the case of Kinesis, this integration exists as well. And basically what you can do, you can just say use a Kinesis stream as a source for a Lambda. And what happens is that as new data is available in the stream, your Lambda will be triggered and you will get an event that describes the data in the stream. A little bit more involved than that, of course, because you might want to configure how you get the data, how many Lambda gets executed concurrently, and things like that. So, of course, this integration is something you can configure, and there are specific parameters you can use. You can also do things like aggregations. I think it's called tumbling window aggregation. So you could configure this integration to, as it's going through the stream, aggregate some data and then trigger your Lambda with already a partially aggregated result. Mm-hmm. So you can even let this event source mapping do some of the work for you and just trigger the Lambda with some partial value already calculated. Other interesting thing is that you could define rules to filter events. So you could specify a filter that tells you I'm only interested in triggering the Lambda for events that match certain conditions. Another interesting one is the batch size window count. So for instance, you could say, I want to receive, let's say, I don't know, batches with 30 messages. So I want to trigger a Lambda when I accumulate 30 messages. But you can also say, unless maybe a certain amount of time has passed. So I want to receive a smaller batch if I'm waiting too long. So you could configure this batch size and window to say, what's the maximum amount of time you want to wait? Or if you can produce batches of a certain size within that unit, start to trigger the Lambda anyway. Another interesting one is the parallelization factor, which is what is going to tell us how many Lambdas we are going to potentially spin up concurrently for processing that particular data stream. And basically what you can say, you specify this value, and that value gives you the number of Lambda concurrently per shard. So let's make an example. If you have two shards and you say that the parallelization factor is 4, I think you get 8, up to 8 concurrent lambdas at any given point, right?
Yeah.
Am I missing
an interesting thing?
there?
I just wanted to chime in there to mention. We mentioned that ordering is strict per shard. So if you haven't dealt with this with Lambda before, you might be wondering, well, if ordering is strict per shard, how can it do multiple concurrent lambdas for one shard? And event source mapping also manages that for you. So what it means is that if you've got the same partition key, so the partition key is quite important here. If you've got the same partition key for a message, it will guarantee that messages for the same partition key will still be order guaranteed for each concurrent Lambda processor. So even though the hash key is different, it'll allow that the hash key will allow it to give that concurrency per shard, but you'll still get strict ordering per partition key within that. So it's like an extra level of order guarantee there. So it works pretty well, but you just have to make sure that the ordering guarantee matches your expectation.
That's an interesting one. I was not aware of that one. Okay, do we want to get to the end of this episode by talking maybe about some of the integrations that you could get with Kinesis, Data Streams, and other AWS services?
Yeah, we mentioned EventBridge already because we said you could take events from EventBridge and put them into Kinesis Data Streams to make metrics and all sorts of useful things. But there's also a couple of interesting kind of change data capture possibilities you can do with data streams. You know, when people are using streaming applications, one of the other use cases we didn't really talk about is kind of like event sourcing, where you're using a complete history of events to accumulate the state of a system, like in a financial application. So change data capture is quite common in some fields, and people are using the changes in the database as an event source for aggregation, for reporting, but also for real-time calculations. And you can integrate Kinesis Data Streams into DynamoDB and get a change data capture, and also for Aurora in RDS. So it'll give you a continuous stream of database changes coming from your tables, and you can either aggregate that or use it to accumulate state based on a history of records. So you've also got the other two products in the Kinesis family, and this is sometimes, the branding and naming confusion, but we talk about Kinesis sometimes as if there's only Kinesis Data Streams, but you've also got the other ones. Do you want to talk about what those are and what they can give you?
Yeah, so you have Kinesis Data Analytics, which is if you ever use Flink, Apache Flink is something very close to that. Probably implements the same API, or probably is using Flink version, directly. Yeah. But it's basically you can define processing logic and aggregation in real time directly on the stream. So you're basically define how to get the data, aggregate it, and produce new data. So it's kind of that analytics use case is the best use case for seeing this particular Kinesis variation. The other one is Kinesis Firos, which is also quite common. And the idea is that sometimes you just want to flash all the data in a stream somewhere. So rather than writing all that integration yourself, you can use Firos, and integrates automatically with things like S3, Redshift, Elasticsearch, or even APIs through API Gateway, or directly calling HTTP endpoints. So that's a good way when you just want to store the data or propagate it somewhere else. You just use Firos, write it to the stream, and let Firos do the rest of the integration. You can also use that, by the way, to connect different Kinesis data streams together, because you could use Firos to say, move the data from one stream to another. So the destination on Firos can be another Kinesis data stream. There is another one, I think, related to videos. You can even have Kinesis video streams, but I will leave that aside for this episode, because it's a little bit of a snowflake. I think the naming is confusing. In reality, it's in the family of video services. Should we mention maybe some material for deep diving on the topic?
There's there's a must read on Kinesis, actually, I believe, because the documentation can be difficult, as it often is. But there's a 2-part blog post by Anahit Pogosova, which is almost like the de facto manual, I think, for Kinesis at this point. So we'll provide the links to those in the show notes. And everything here we've covered is covered in really just comprehensive detail really well in those articles. We mentioned that we'll be talking about Kafka as well. So there's a comparison by the Cloud guys between Kinesis and managed streaming for Kafka, which is definitely worth checking out. There's accompanying video with that. I also saw a really good one in reInvent 2020, which is a deep dive on using Lambda specifically with Kinesis by Hiki Park, and we'll provide the link to that one too. But that talks a lot about how it's implemented under the hood and how standard consumers work versus enhanced fan-out. Really worth checking out. So if you're looking at Kinesis, because you have to consider how they work and the limits so much, there's a little bit more investment in your time as an architect or a developer with Kinesis and streaming data in general. I think it's worth taking, a couple of hours looking at those resources, and you'll feel much more prepared.
That's great. Yeah, I think with this we have covered a lot. This is probably our longest episode ever. So by the way, feel free to let us know if you prefer longer and more in-depth episodes, or if you prefer the shorter ones, because of course we are always experimenting, and it's great to have your feedback on that. With that, let's keep in touch. Make sure to follow and subscribe if you want to be notified about new episodes, especially if you're liking this event and messaging series. You can get notified when we publish the next one, which, as Owen said, is going to be about Kafka. And again, don't forget to connect. We are looking forward for all your opinions. And if you have used Kinesis, we're curious to know your use cases. If you had any trouble with it, surprises, because all of that is something that we can share and learn from each other. See you in the next episode. Bye.